This is an interesting ladder problem where the ladder is not up against the wall, but resting on top of a wall. And I'm just going to read through the question and then add to a diagram. I've actually made a much larger diagram here because I think, there's a lot going on it and you've got to be able to distinguish and ultimately, solve the problem using the diagram. Right, I'm just going to underline any keywords. So we've got the ladder AB, the length is 2A, that's already labeled. Mass mg, that's going to come in a minute. It's resting in equilibrium. So straight away, that means there's no resultant force, so we can use that idea, and there's going to be no resultant moments. Okay, so with rods or ladders, you need to take that into account as well. This is a moment and force problem. A vertical wall of height h, the ladder is inclined at an angle of 30 degrees to the horizontal. A is in contact with the ground, and then an object of mass 2m is placed on the ladder at C, where AC is equal to D. So, okay, before I get on to the next bit, I can add a few things to my diagram. So this here is going to be a weight, and it's going to be 2mg. There's going to be a normal reaction force from the ground, and I'll call that RA. That's pretty much everything so far. But then we're told the ladder's modeled as uniform. That means the center of mass is going to be in the middle. So let me add that on at this point. Okay, now it kind of looks like C is in the middle, which is a bit frustrating. So I'm just going to move it here. This is going to be where the center of mass is, mg. And then this distance is A. Okay, look, it might not be drawn accurately, but I wanted to move it far enough away from C rather than have them like basically identical. And after doing that, I'm just going to add this perpendicular line in. So this is going to be 30, and that angle there is also going to be 30. We're told that the ground is rough and the vertical wall is modeled as being smooth. And then we're asked to show the normal contact force is given by this. So normal contact force between the ladder and the wall. Well, you might think, is it going like up? Is it going to the left? And the answer is it's a bit of both. It's going to be going in this direction. And the reason it has to be, it has to have it has to have we'd expect it to have a vertical component, of course, because it's the ladder's resting on it. And it has to have a horizontal component because there's going to be a frictional force. Is it acting to the right? Is it acting to the left? Well, in either case, there's got to be then a horizontal component over here to cancel it out. And if you think about it, the ladder, it's not going to start slipping up the wall. It's going to slip. Gravity causes things to go down. So the ladder is going to be trying to move, like slip to the left. It's not actually moving, so I don't need to put that arrow on. But what it means is the frictional force is going to be acting to the right. So this is going to be FA. And that's another reason then why the normal reaction force here has to be acting to the, like have a left component to cancel it out. So I think that's maybe the trickiest bit of the setup. Maybe you had no problem with it, but it's going to be, I'm going to draw it going at right angles here. And I'll label this, it's not technically RB, I'm going to say RW because it's where it hits the wall. So if I draw a line continuing up, I can see that this is going to be 60 degrees, that's 90, which means that angle, the vertical now, is going to be 30 as well. So we're asked to basically find this normal reaction force, normal contact force, Rw, in terms of A, D, and H. Now there's one thing I've not yet done, I've just realized, and that is work out the distance, this distance here. It's going to be quite important in a minute. So if I draw the triangle just a little bit smaller away, I've got H and I've got 30. So I can use trigonometry, I can write down that sine 30 is going to be, and this is question mark, is going to be h over question mark. So question mark is going to be h over sine 30. Sine 30 is a half, so it's actually 2h. This distance is 2h. Okay, that's another little subtle thing, but that's something you're gonna have to figure out along the way. Okay, now what do we do? Right, what we don't do is start resolving forces because we don't know what RA is and we don't know what FA is and we don't know what RW is. If you're just going to start creating equations with too many things that you don't know, it's not going to get us the answer. Instead, we need to take moments. So taking moments is great because you can immediately eliminate a lot of the forces. We can do that here by taking moments at A. So as soon as I take moments at A, there is no component from FA or RA because they are the same, well, they're zero distance away from A. Remember, it's a perpendicular component of your force multiplied by the distance from where you take moments. So let's first of all look at the clockwise moments. So let's say this is fixed here. The two weights are going to try to bring the ladder down this way, i.e. rotate it clockwise. So I'm going to get 2mg, but the perpendicular component is then going to be cos 30. I'm bringing it into the angle, that's why it's cos. Or you can draw your triangle and see that it's the adjacent, or you can basically work out, you can split it into components if you want, but it's going to be 2mg cos 30. And then I'm going to multiply by the distance from where I'm taking moments, so it's going to be d. Then I'm going to add mg cos 30 multiplied by a, because remember it's halfway along the ladder, and that is going to equal RW. Now RW is actually acting perpendicular already, so there's no cos or sine going to come into it, and I'm just going to be multiplying by 2h. Okay, pretty happy with this. We've got an equation, and the only thing that we don't know, but well, okay, we don't know lots of the things, but the thing we're trying to find we can now write in terms of everything else. So first of all, let's get the exact values of trig involved. Cos 30, put it in your calculator or you may know it, it's root 3 over 2. Now, there's different ways of doing this, but not a bad idea, I think, is to multiply through by that 2. You might prefer, because otherwise we might get fractions within fractions if we start dividing straight away by 2h. So 2mg root 3d plus mg root 3a is going to equal 4hrw. And this is quite nice because we can see we've already got the 4h. So I just need to simplify the rest of it. And I can even look at the answer and to help guide me. So mg times 2d plus a, and then a root 3. So it's making us put the root 3 at the end, which I find a little bit strange, but anyway, we factorized out the mg to the left and factorized out the root 3 to the right, and if you multiply back through, you will get the same thing. This is equal to 4h rw, which means rw is going to be mg. Now, I'm just, because in their answer they've swapped them around, I'm just going to swap them around here. A plus 2d times root 3 over 4h, and we're done. Now, if you don't, I just want to sort of quickly talk about this. If you decide, like I did in the actual question, I kind of multiplied through, so I got mg d root 3 plus mg root 3 over 2a equals RW times 2h. If you decide to go this route, you just need to be a bit careful when you then divide by 2. And I would actually say, you know what, put it over a common denominator. Let's just do that. And then when you divide by 2h, it's the same as just timesing the bottom by 2h, because it's the same as timesing by 1 over 2h. So you can just do that. I'm just talking about little, bits of technique if you're less confident on your algebra. Um, and then once you're here, we're back in the same sort of place. You can just collect these terms together. Okay, so part B, 7 marks. It's given that the equilibrium is limiting. What that means is it is about to move. Okay, not moving, but it's about to move. The key thing then is that the frictional force, Fa in this case, is going to equal, not just be less than, or less than or equal to, it's going to equal mu times Ra. So that's going to come into it. And we're told that mu is 1 over 8 root 3. And I'm asked to show that h is equal to this. Okay, so this is probably the most awkward part of the whole mechanics section, to be fair. Right, I'm going to be sort of hopping up and down this, there's lots going on here. So first of all, actually, I'm going to write down that Fa is 1 over 8 root 3 Ra. Okay. Now we need to somehow link together. Well, it doesn't actually, it's not really any, clear guidance as to what direction to head. But I suppose you've got to think, right, we have taken moments. Normally, when you've got this sort of question, you also resolve forces. So let's do that. Like doing more moments isn't really going to help. Or maybe it will, but it's definitely a bit more complicated. So instead, I'm going to resolve forces. First up, I'm going to resolve forces in the vertical direction. So resolve vertically. Then I see I'm going to get Ra plus the vertical component from Rw. So it's going to be Rw cos 30. Now remember, we have found Rw in the first part. Here it is. But I'm not going to write that in at the moment. Okay, that's quite complicated. So let's just leave it in terms of Rw. And that is going to equal the weight acting down, 3 mg. Okay, and then we'll resolve in the horizontal direction. There's less forces here. So we've got a frictional force acting to the right, and then it's going to be Rw sine 30 acting to the left. So they're going to be equal. And remember, Fa is equal to root 3 over 8 Ra. Sine 30 is a half. So that means I'm gonna yeah, I want to get right. I could substitute in for RW, but no, I don't want to do that because I've got RW. So I want to basically, right, where am I going with this? Let me just sort of pause and say, I've got this equation here, and remember, I know what RW is. Okay, it's in terms of some of these other unknowns, A, D, these parameters, I should say. Um, so if I can replace RA here with some other stuff that I know, then I'm ready to substitute in and basically try to get to this. So we've resolved horizontally. We've now managed to get RA and RW as an equation. So I just need to make RA the subject. So I can times through by 8 and divide through by root 3. It's going to be 4 root 3 RW. And therefore, 4 root 3 RW plus root 3 over 2, because that's cos 30, RW is going to equal 3mg. Now, it might be very tempting at this point to substitute in for this, but I just urge you not to yet. Let's sort the fractions out before we do. Okay, so yes, we've got this in the background ready to use. And okay, let's also just write this down. That's what we're trying to get. Okay, but we can put this over a common denominator. Now, the first thing I'm going to do actually is like rationalize the denominator of the first term. So it's going to be 4 root 3 over 3. Right, that's going to be much better now. Okay, then I'm going to factorize out RW and times top and bottom of this one by 2. So it's going to be 8 root 3 over 6. Top and bottom of this one by 3. So 3 root 3 over 6. This is going to become 11 root 3 over 6. So therefore, RW, you can either divide by the fraction or times by 6 and divide by 11 root 3. So that is going to give me 18 mg over 11 root 3. The only thing I don't like about this is that there's a root 3 on the bottom. So I'm going to times through by that. 18 root 3 mg over 11 times 3. And that 3 is going to cancel with the 18 to leave me 6. I've got two equations for RW, and I can now set them equal. So therefore, 6 root 3 mg over 11 equals this on the right. Okay, I gotta be honest, when I did this, I didn't straight away go to that. I did it later on. It's not always obvious what order to do things, but at this point, it's good, you need to realize it, because then once you've realized it, they just cancel out. And these cancel out as well. Super. Let's cross multiply. 24h is going to equal 11a. Wait. Don't multiply that out. Remember, in the final answer, we've actually got a plus 2d, so I want to leave it in a bracket. 11 times a plus 2d, which means that h is 11 over 24, a plus 2d. And that is our answer. Okay, good. Yeah, well done if you managed to do that. I hope it's making sense if not. We're nearing the end of this question. Just a few little marks at the end. So first up, hence find in terms of A the greatest possible value of D. So the first thing I'm actually going to do is kind of rearrange this formula again to get it in terms of D. Therefore, I'm going to get 24 over 11h is equal to A plus 2D. So I can then minus A and divide by 2. It's going to be 12 over 11h minus a half A. So trying to find the greatest possible value of this. You just need to think back, are there any limitations to h, basically, because we've got a here, so it's all about this term. And let's take a look back at the very first diagram. So can h just get bigger and bigger forever? And the answer is no, it can't, because we had here a distance 2h, and there's no way that that can be greater than the length of the whole beam. It must be that 2h is less than 2a. 2a was the whole amount along. And that gives us what we need. 2h is less than 2a. So h is, I suppose I could say it's less than or equal. So h is less than or equal to a. And therefore, the max value of d, you could call it the upper bound. It might not actually be able to equal it, but it can equal any number less than that. And that's enough. So it's going to be 12 over 11a minus a over 2. So 24 over 22a minus 11 over 22a, which is going to become 13 over 22a. That is going to be the greatest possible value. Finally, we're asked to state an improvement that could be made to the model. So a good shout, I mean, there are some sort of standard ones, but a good shout is to like look back at the problem and look at where we made an approximation. And the one that jumped out to me was the vertical wall being modeled as smooth. So I put that one as my answer. I said, yeah, model friction on the wall at the point of contact with the ladder. Let me just show you the mark scheme. So for other ones, it's it's good at this point to talk about these because that's as well as solving problems, we're trying to have an awareness of the fact that we are modeling and the assumptions that we've made. So we could model the ladder as non-uniform. This is the one that I said. We could consider the dimensions of the object at C because we've considered it a particle, consider the thickness of the ladder, or allow it to bend. What was not allowed was removing friction from the ground. Actually, that would make the model worse. Or using a more accurate value for gravity. Actually, G cancelled out in our equation. It didn't come into it. Good question, I think. Tough, but good.